the economics of running AI at scale. Yesterday, Google made Gemini 3.6 Flash. Google just released its latest Gemini models, but this is not the blockbuster flagship launch that many people were waiting for. Instead, Google released something that much more mattered for businesses and developers, and faster, cheaper, production-ready AI models designed specifically for agents. The real story here is not simply intelligence, it is the economics of running AI at scale. Yesterday, Google made Gemini 3.6 Flash and Gemini 3.5 Flash-Lite generally available. And a limited access cybersecurity model called Gemini 3.5 Flash Cyber was also announced, but it was given to governments and selected trusted Google partners. Google is positioning Gemini 3.6 Flash as its workhorse for coding, knowledge work, multimodal analysis, and agentic tasks. Flash-Lite is designed for high-volume work such as extraction, classification, routing, subagent execution. Basically, what the enterprise actually does. The distinction here is important because Google is not asking companies to use one expensive model for everything. It is effectively offering two layers of intelligence inside the same ecosystem. The timing also tells us that something about Google's broader strategy. The more anticipated Gemini 3.5 remains in partner testing, while Google has also indicated that its ambitious Gemini 4 pre-training run has begun. And as you know, Google DeepMind is really well versed in doing some innovative things per se. So this is not necessarily Google's final frontier model response to OpenAI, Anthropic, Meta, or even Gemini 3. What is coming in? What has just shocked the world as of now for all the proprietary models? It is a tactical release aimed at immediate adoption. Google appears to be saying, while the market waits for the next flagship, which is off the chart, here are the models that businesses can afford to deploy today. That makes this release less exciting as a benchmark spectacle, but potentially more consequential for real production systems. So what has actually Google changed? Google says Gemini 3.5 Flash performs better on coding, planning, multimodal tasks, long context analysis, while a few reasoning steps, fewer tool calls, fewer output tokens. According to Google's launch material, it uses approximately 17% fewer output tokens than Gemini 3.0 Flash on artificial index. This matters because agents' costs are not determined by the price of one token. They are determined by how many tokens the model generates and how many tools it calls and how many times it repeats or corrects itself before completing a task. A slightly smarter model that finishes a workflow in production. Google has released a standalone technical paper for Gemini 3.0 Flash. Instead, the public architecture story comes from a chain of model cards. The 3.6 Flash model card says it is based on Gemini 3.5 Flash. That basically looks like an incremental upgrade. The 3.5 Flash model card says that model is based on Gemini 3 Flash. The deepest architectural description for Gemini 3 family comes from the Gemini 3 Pro card model card, which describes a sparse mixture of experts transformer with native multimodal capabilities. In simple language, a mixture of expert models does not activate every part of the network for every neutron. It routes the task to selected internal experts. This can give model access to substantial overall capacity without paying the full computational cost for every request. And we all know that Google has this advantage of having silicon till the last token, in which they have their own TPUs, and they can go ahead and have models who can generate tokens as well. So that gives a significant advantage to Google. Operationally, Gemini 3.5 Flash has a broad capability surface. It's a multimodal model. It accepts images, text, audio, video, PDF inputs, produces text output. It supports approximately 1 million input context. So the context is large enough, up to 64,000 output tokens. That's probably a little bit less when you're looking at doing agentic tasks, but if you're looking at having sub-agents and those kind of things, probably would fit in. It also includes capabilities such as structure outputs, function calling, code execution, file search, URL context, basically a lot of things which really matter. So Google search, maps, computer use, that's what makes the models more than a chatbot model, I would say. And because in other contexts you would have to go ahead and add all of these things. Now Google inherently, since it has all of these capabilities, it's trying to integrate all these capabilities for enterprises and for customers. It can also potentially examine a document, interpret a chart, and search for supporting information, call a business system. Uh, all of the things which we are expecting these days with latest frontier model. Now let's take a look at the benchmarks. Starting with Gemini 3.5 Flash against Gemini 3.5 Flash. According to Google's official table, the SUI Bench Pro rises from 55.1 to 58.8%. Deep SUI moves from 37 to 49%. MLE Bench moves again. OS World computer use is pretty significant, and Google's knowledge work score also improves. Now, I always take these measures as a grain of salt, because sometimes you are actually training these models to pass these tests as compared to for general intelligence, and that's what we can see in the real world. Results can be really smart and really same time as well. So I would go ahead and look at these, but I would actually want to do my own evaluations on these tasks. Now, Flash-Lite may be actually more commercially interesting model because it's fast. That's what Google is claiming. Google results show that Gemini 3.5 Flash makes a substantial gain over Gemini 3.1 Flash-Lite, and that's pretty important, because imagine in a customer service environment, you're talking to the customer, and you would need those results faster, no matter how cool is the technology, how cool the agents are. But if they don't deliver the results in the right time, the actual ROI or the actual benefit starts to disappear. So I really like this functionality in terms of going as fast as possible and reducing latency. The other things, the third-party picture, I would say, is a little bit more balanced. The Supply Research places Gemini 3.6 Flash is in a strong competitive tier with artificial analysis index. I would say it's not at the top, but hey, you don't need to solve physics Olympiad problems every time. All you need to do is a certain task which you can actually go ahead and use these models. If the model is faster, cheaper, and has less latency, and it's reliable, that actually defines business value. And some of the premium OpenAI Anthropic configurations remain ahead in the composite intelligence measures, and that is why the correct claim is that Gemini 3.6 Flash is not always the smartest model. But as I was saying, we don't need a smartest model to do all of the things, do the tasks broadly with the intelligence of the models which we already have. And for many companies, an 80-90% solution which costs less as compared to an expensive solution and responds most faster can generate much more value as compared to being the best and going for 24-hour searches. And the important metric of evaluation is therefore not a model score alone. It is successful business outcomes per dollar. Google is also transparent about several limitations. The models can still hallucinate. And trust me, I've been in the industry for 2 decades. I can say the models do hallucinate. ChatGPT or Open or other models would still tell you, there are 2 R's in a word strawberry. Sometimes they do it, sometimes they do. So hallucination is still a problem, and it can sometimes have occasional slowness and timeouts. But hey, it's with every model. Jailbreak resistance remains an area of continued improvement. Google developers guidance also notes an interesting trade-off in code generation, and Flash may produce more functional code, but previous models were sometimes preferred by human evaluators for visually styling and layout. So that means that a developer asking it to create an application interface may receive functional code that still requires clearer brand design systems, layout instructions. This is a useful reminder that benchmark performance does not replace specification quality. Better models still need well-defined requirements in code testing and human review, particularly in high-stakes or customer-facing workflows. Safety becomes especially important when the model can use tools and control interfaces, and Google says that Gemini 3.6 Flash includes a strengthened safeguards for chemical, biological, radiological, nuclear misuse, as well as cyber offense scenarios. Google also says that it has improved jailbreak resistance while attempting to reduce unnecessary refusals for legitimate users. And the company's model card states that the model is unlikely to reach the critical capability thresholds defined in the Frontier Safety Framework. So there is another framework which they've quoted as well. This does not mean that the model is risk-free. and none of the models are risk-free. As I would say, in Google's testing currently places it's below capability at which substantially stronger deployment restrictions would be required. For enterprises, the more useful question is not whether a model is simply labeled safe. It is what controls around the model when it is connected to real systems. So think of model harnesses, the databases. Now, computer use is where is a great example. And a browser or a desktop agent may counter text instructing it to ignore the user and take a different action. That is an indirect prompt injection. Google recommends a defense in-depth approach that includes sandboxing, restricted permissions, and human verification. It has also documented two particularly practical controls. The first is user confirmation, so having a human in the loop for irreversible actions such as purchasing an item, transferring money, or deleting. So we are in an AI race, but there is still a human in the loop is what is being said by a company like Google. So that says something about the state of models where we are as of now. The second is automatically stopping a task if indirect prompt injection is detected. So these are two fundamental controls which they have suggested for computer use. Now, for developers, there are some really big changes, which I would say, because for a long time, we've played with temperature, top P, top K, and we've tried to play with those parameters. But the new APIs which Google is recommending, which is called the Interactions API, as a preferred way to build the latest Gemini models and agents. The emphasis goes more on system instruction, structure output, and tools. The stable identifiers which Google is pointing now has also basically they're starting to deprecate a lot of parameters, sampling, temperature, as I was saying earlier. They're also suggesting that this is the way things are going. So if you already have some code which has these parameters, it would be a good idea to put them back in the reviews because 3 months or 6 months down the line, most of the labs will probably start adopting the best practice if this model becomes successful as well. Now, pricing is where Google's just wins very clear. Standard pricing for a 3.6 Flash is listed at $50. Per million input tokens and $750 per million output tokens. Gemini 3.5 Flash-Lite costs approximately 30 cents per million input and $2.50 per million output. And it's just pretty remarkable that they are able to get this money. Flash-Lite also has lower batch and flexible processing prices, so you can literally go ahead and reduce this price further. If you're looking at a batch, if you have processes or if you have functions where you can go and look at batch pricing. Now, by comparison, contemporary and balanced or frontier scale offerings from other major vendors are substantially more cost more, and particularly on the output. But the tokens are the only starting point. Search grounding, map grounding, repeat tools, a lot of other tools should also be included in the full cost of completing a workflow or a task which you're saying, not just merely advised input price token. And having said that, I think that also gets added in the other model providers or other models, but I would want to look at that as well. The practical architecture for many organizations will be a tiered model stack. Gemini 3.6 Flash can act as a planner or a primary executor. It can interpret complex instructions, coordinate tools, analyze multimodal information, and handle difficult exceptions. Flash-Lite can perform the repetitive volume underneath it. So think of extractions, classifications, translations, routing, and data preparations. Model from Google or any provider can still be introduced for small number of tasks required, the highest available reasoning quality. So think of it as horses for courses. What model would you want? You can also include open source, which I'm a really big fan of. The approach would reduce cost and latency while preserving access to a stronger intelligence when necessary. It also reduces vendor lock-in if the orchestration layer is designed to evaluate and route tasks based on measurable requirements rather than brand preference. The short-term impact will be strongest in software engineering, quality assurance, document-heavy analysis, customer support, and content operations. Engineers will spend less time producing drafts of code and more time defining architecture, which we are already seeing with other models across. So there is nothing new which is coming here. also in finance, legal, consulting, will supervise the systems and extract the evidence and prepare initial reports. So I'm there is nothing new which is happening here. The only thing is it's a little bit better intelligence with low latency, which we are getting from Google. So what should a business do now? If you already have Gemini, I would say have an evaluation checklist and go ahead and test the model whenever it's available in your area, because one thing is the model being available in America, but the model has to be generally available in various parts of the world, in Europe, in Asia Pacific. So once it's available, have a plan ready, just to go ahead and do a quick red teaming to see whether this is better for you. My advice is do not migrate just based on the benchmark tables. If you see benchmark tables, I normally say run away, because you don't know which model is actually trained for the benchmark table, and you don't get the right results. Go ahead and look at run representative internal tasks and measure accuracy, latency, token, tool call success, retry rates, total cost per completed workflow. For autonomous computer use, begin with narrow tasks. Think of already tasks which you're doing it. And frankly, if you think that you're already getting some success, I wouldn't really go ahead and change my models as of now. I would just go ahead and use the same model. And if your workflow is highly regulated or expected to remain unchanged for years, examining the model lifecycle guarantees. So whatever the current model you're using, what is the lifecycle till when does it get deprecated, fallback, and can this model be a fallback options before the model before making this model a permanent dependency for your architecture. My final assessment is that Gemini 3.6 Flash is not necessarily Google's final answer in the frontier model race, but it may be one of the Google's strongest answers to business problems actually have. How to run a capable AI agents without allowing cost, latency, risk to spiral out of control. The question is no longer simply which model is the smartest. The better question is which combination of models, tools, and controls reliably completes my workflow at the right cost. On that measure, Google's position has just considerably become stronger.